Hello students, how are you? I am your Mistri sir. In these sessions, I am going to discuss a part of physical chemistry, solid state. In this video, I shall discuss basic of introductions part of solid state with some basic or genuine questions like what is solid state, why it is important to us, and why we discuss in this session solid state and in which field we applied the solid state. In those basic questions we will discuss in this chapter in this video. It is very big problem of many students. They don't know. That's why learn to a particular topic or chapter like solid state and many other chapters. I want to suggest you it must be in every kind of topic or chapter has achieving your goals. Otherwise you will quit all kind of topic or chapter which is not important role play uh, play your goals. One more thing I want to tell you students, now it is very important. Now solid state depends on the imagination's power. If you have much more imagination's power, you will solve quite easy all kind of questions of solid state. And this video give clear idea about maximum trends of solid state. That's why important of solid state chemistry in our syllabus. Now concentrate and watch. I am sure by the end of the video you will be just perfect and maximum of all the questions solved in solid state chemistry. Now, first of all, here it is syllabus of solid state. Now, first of all, we will discuss general introductions of solid state, type of solid state. Now, classifications of crystalline solid on the basis of binding force, crystal lattice and unit cell, packing of particles, voids, calculate packing efficiency. Sorry, correlate the density of substance with its cell properties, imperfections of solid, electric and magnetic properties of solid. Okay, let's begin the topic. First of all, introductions of solid state chemistry. I am not going too long. Now I come to the point. We all know matter exists in three states. These are solid, liquid, and gas. They differ in interparticle space, which are least in solid state and maximum in gaseous state of substances. The interparticle space responsible for the force of attractions, which are maximum in solid state and minimum in gaseous state. Since the constituent particles very close packed in solid state, they can only oscillate in their mean positions. That's why solid has negligible fluidity as well as rigidity. Now it is very important in this chapter, in this video, use of solid state or importance of solid state. If you have applicable applications of any kind of substances chapter or topic, now you will learn more curiosity. So that's why I want to tell you we have surrounded by a very vast variety of solid object which is differ in size, shape and also mass. The metal are a backbone of our industries. Our scientists have worked extremely hard in developing new materials like both low temperature of superconductor and high temperature of superconductor. Students, you know what about superconductor? Now, superconductor has a wide range of applications in the field of electricity. In this present unit, we shall focus mainly on the crystal solid. We shall discuss their type of nature of packing, structure, and type of defects, even magnetic properties or electrical properties of solid state. The point of view chemistry the point of view chemistry, the branch of chemistry which deals with the study of crystal known as crystallography. That means the solid state chemistry deals with crystallography. So definitions of solid state. A solid state is defined as that forms of matter which possess rigidity that's now another definitions of solid state. Now you can see the uh, that solid state of matter in which constituent particles are bonded with a strong force of attractions. It is a abbreviated form, CP, that means constituent particles, FOA, that means force of attraction. So after definitions, we will see the properties of solid state. Now first, it has definite shape, size and volume. Now can you guess now why a solid state have definite shape, size and volume? Now let's see students, now why solid state have definite shape, size and volume. Now you consider constituent particles. Okay. Uh, Now solid state constituent particles, they are only mean positions. That means these constituent particles means ion atoms or molecules uh, don't go don't go that side. Okay, don't touch their surrounds. That means it has to be go maximum, here it is, here it is and here it is. That means they do not replace to each other, they do not overlap to each other. That means they are only vibrate. So it is fixed volume, shape and size. Okay, second point, that is low compressibility. That means it is a very low compressibility. Compressibility means pressure. That means the same kind of explanation, that is mean oscillations. So that's why it is low compressible. And next one is low flexibility. Again the same explanations of low flexibility. That means it has only mean oscillations. Their constituent particles don't move, don't replace, don't overlap to each other. And next one is low diffusion power. Now can you say what about low diffusion power? That means their constituent particles attach to a strong force of attraction. So that's why they move to one place to another. That means they don't move to one place to another because due to having a strong force of attractions. Okay, next very high melting point and boiling point. Now same kind of explanations. High melting point and boiling point. That means their constituent particles having the strong force of attractions. So that's why the thermal energy we will provide much and much. So melting point and boiling point having high. It has good conductivity and electricity and heat. Now types. It is very important for IIT, JEE, and NEET also. Now in this segment, one or more than one questions arises. Many competitive examinations. So it is very important. Now first of all, types on the basis of closely packed. So it has to be two types: crystalline solid and amorphous solid. Crystalline solid, it is a regular arrangement of constituent particles for long range. Now, what about long range? Long range, that means it's must be minimum 100 angstrom constituent particles. It will be arranged in regular pattern. Now you look like a black spot and red spot, just like a positive negative positive negative positive negative positive negative. That means it has been found in ionic crystal. So ionic crystal having positive or negative. Now while amorphous solid, solid having regular arrangement of constituent particles, but short range of order. That means they are going to more than below 1,000 angstrom, below 1,000 angstrom. Just you see, now here it is black red black red, that means positive negative positive negative positive. Now after that they are a big interval, they are big interval. After that again they are going to a short range, that means they below 100 angstrom, 100 angstrom. Now crystalline solid having true solids, and amorphous solid having pseudo solids. That's why it is called super cooled liquid. And what you understand, what about super liquid? Just like you see about your surrounds many things, just like a glass you see. Now the bottom side of the glass having the thick, and the top of the glass having very thin. That means just like a plastic chair. Now you will you will burn the plastic. Now you will see the plasticated materials. Now first of all having soft, after that they are flowed. Okay, next is the melting point is very sharp melting point. That means fixed temperature, just like a sodium chloride. Suppose sodium chloride having 60 degrees Celsius, they became to melt, solid state becomes melt. They do not melt 59 or 61. That is why called as sharp melting point. They are mainly having 60 means 60. Now amorphous solid has melting point is range of temperature. Range of temperature means they are move on the temperature, just like 50 60 70 80 90 20. Now whenever you burn on the plasticated material, now first of all they are sharp. After that melt, that means their temperature is not fixed. Now next one is anisotropic in nature. What is the sense of anisotropic in nature? That means different physical properties in different directions, such as the magnetic strength, electrical conductivity, refractive index, etc. Now it is having the positive negative. That means having a ionic crystal. Now we arrange the different path. Now it is look on the amorphous solid. That means same properties in the different same physical properties in the different directions, same physical properties in the different direction. That means positive negative positive negative positive negative. If we across the left to right, that means they are different in different constituent particles. But whenever we across the cross we across the cross, they are different constituent particles, and we are going to straight line, they are the same physical properties. That means anisotropic properties, it is very important properties. And last examples how to understand anisotropic and isotropic substances. Okay, just like a marriage ceremony, that means an isotropic and not arranged, and isotropic. That means if you go in the buffet system, that's are all kind of peoples are randomly. That means uh, ladies, gents, childrens, and all kind of peoples having the same place. Many ceremonies having the linear form or the arranged form, that means girls one side, um, boys one side, and senior citizens one side, that are anisotropic properties. And it is very important cause of an isotropic, it is different arrangement in different directions. For example, squads, NaCl, KCl, calcium fluoride, etc. And amorphous solid has glass, plastic, rubber materials, etc. Now, last of the topic, the applications of amorphous solid. It is so much important. Amorphous solid, just like inorganic chemistry, glassware, labware, etc. Rubber, tire, rubber industry. That means tire, shoes, soles, etc. Plasticates, all kind of plasticated materials. And photovoltaic, it is so much important. Photovoltaic cells, best material for the converting sunlight into electricity. That means the sun charger. Now, last topic of the video, the types of the crystalline solid on the basis of the constituent particles. Now, crystalline solid further divided four types: ionic solid, metallic solid, covalent solid, and molecular solid. Okay, now you will all the categorize this type of tabulated form. First of all, constituent particles in ionic solid. Ionic solid constituent particles is ions, and ions that's a positive or negative. Metallic solids, that means that constituent particles is metals atom. And next one is covalent solid, that means non-metal atoms. That means metallic atom, non-metallic atoms. Metallic atoms situated on the periodic tables, that's left side, and non-metallic substances just like after carbon group. And next one is molecular, that means molecules of the atom. Next is force of attractions. So ionic solid having electrostatic, ionic, or the Coulombic force of attractions, and metallic solids have the metallic bond, and covalent, definitely we all know covalent bond, and molecular force of attractions, molecular solid having van der Waal forces. Okay, next one is boiling point and melting point. Ionic solid having high. Why it is high? Ionic solid. It is very important for us. Many questions will be arises in this portions: melting point and boiling point, and as well as conductivity. Now, ionic solids having high, metallic solids having also high, but covalent solid very high. It is so much important. Covalent solid having very high, and molecular solid very low. Molecular's melting point is very low. Next one is conductance. In the molten state, that means ionic solid conduct on the electricity only molten state, just like NaCl. But solid state, they do not conduct electricity. And metallic solid having highest conductivity, because metal have free charges, free electron, so it has a kernel and the kernel electrons, that means electron cloud. Just like ferrous release to iron release to electron, the another iron release to electron, it is also 2 electron. Now that's why it is millions of billions iron metals having released two electron, that means two times all kind of metals release on the free electron. That's why it is conduct much more, that means highest electroconductivity. And covalent having least conductivity except of graphite and diamond. And molecular having very low. And example, it is so much important. Previously many competitive examinations asked in this segment questions, just like examples of ionic solid, NaCl, KCl, calcium fluoride, zinc sulfide, and metallic solids having metal, all kind of metal, just like iron, zinc, copper, aluminum. And covalent solid having carbon carbon, that means carbon carbon, graphite, diamond, silicon silicon, silicon, aluminum, nitrile, etc. And molecular solid having water, carbon dioxide, iodine, and phosphoric acid and phosphate. It is so much important.